polynomial function p of x is equal to the quantity x minus 1 squared times the quantity x plus 3. Find the x-intercepts and determine the behavior of the graph at the x-intercepts. So I'll go ahead and write down the polynomial function. We have p of x is equal to x minus 1 squared times the quantity x plus 3. This polynomial function happens to be in factored form. So it makes it easy to identify the roots or the zeros of the polynomial. So looking at the first factor, we have x minus 1. If I set that equal to 0, I would have x is equal to 1, and that is our first root or our first 0. I'm going to make a table here. So I have the root, which in this case it is 1, and it corresponds to the x-intercept of 1, 0. So this is a point on the graph where the graph will either touch and not cross, or cross the x-axis, depending on the multiplicity of that root. So the multiplicity of this particular root corresponds with our exponent here. That factor of x minus 1 occurs twice. So its multiplicity is 2. And the behavior of the graph at this x-intercept is that it will touch the x-axis. It will touch the x-axis, not cross. Now, for the next factor, we have x plus 3. This corresponding exponent here is 1. This factor occurs once. So we have x plus 3 is equal to 0. Solving this for x, we find that x is equal to negative 3. So our root is negative 3. This corresponds to the x-intercept of negative 3, 0. Its multiplicity is 1. So since this multiplicity is 1, in this case it will cross the x-axis. So let me point this out. If we have an even multiplicity, then the behavior at the x-axis will be that it touches the x-axis and does not cross. If we have an odd multiplicity, then the behavior at the x-axis is that it will cross, the graph will cross the x-axis. So we have 2 points that we can plot. We have the x-intercept of 1, 0, and we have the x-intercept of negative 3, 0. I'd like to go ahead and plot both of these points over on our graph. So we have the point 1, 0, and we also have the point negative 3, 0, which is right here. So we have 2 points on our graph. And now I need to have an idea of where to start my graph. One approach would be to find the y-intercept. So the y-intercept is when x is equal to 0. Here's our polynomial function. P of x is equal to x minus 1 squared times x plus 3. I'm going to go ahead and plug in 0 for x. So p of 0 is equal to 0 minus 1 squared, 0 plus 3. And I'll do the arithmetic. 0 minus 1 gives us negative 1 squared. 0 plus 3 gives us 3. Now I'll do the exponents here. Negative 1 squared is 1 times 3, which gives us 3. And thus, our y-intercept, which is when x is 0, is the point 0, 3. 0, 3. I'll go over to the graph and I'll plot that point. 0, 3. So now I'm ready to graph this function. I'm just going to do a quick sketch. So I'm going to think about what we said about the behavior of the graph at this x-intercept, 1, 0. So that was right here. At 1, 0, we had a multiplicity of 2. Since it's an even multiplicity, our graph is going to touch the x-axis, not cross. So I'm going to come down here and I'm going to touch the x-axis. Touch it right at that point there, and then it's not going to cross, so it's going to touch it and it's going to go back up. It's also going to go through the y-intercept of 0, 3 up in this direction. I'm going to come back and see what's going on at the other x-intercept. The other x-intercept was negative 3, 0. So at negative 3, 0, it has a multiplicity of 1. Behavior at this x-intercept is that it will cross because it's an odd multiplicity. So the graph may go up a little bit here, and then it's going to come back down, and it's going to cross at this x-intercept, and it'll keep on going down there. That's a quick sketch of the graph of the polynomial p of x is equal to x minus 1 squared, x plus 3. So we found the x-intercepts, stated the multiplicity of each, and the behavior of the graph at the x-intercepts.